Assalamu alaikum dear students. Today we are going to start our next topic of Unit 7, Properties of Matter. Our next topic is Applications of Archimedes' Principle. Now Hydrometer. Today we are going to discuss about the hydrometer. What is hydrometer, how they are working, and what is the construction of hydrometer. Now a hydrometer is an instrument that measures the ratio of the density of the liquid, any liquid other than water, to the density of the water. Note, must keep in mind that if object density is less than the density of water, then the object will float. If the object density is greater than the density of water, then object will sink. Means if the density of object is greater, then it going to be sink in the water, and if the object of density is lesser, then it will be float on the water. Clear now? Now the next is that a hydrometer. What is the meaning of the hydro? Hydro means water and the meter means measurement. Now we are going to discuss about the construction. What is the construction of hydrometer? An hydrometer consists of glass tube with a scale on the side of wedged at the bottom with the lead tube. Look at the diagram. At the end you are able to see that it's red, below the red, that there is a lead tube. And look at the upper side, it's called the stem, which we call them a scale stem. On this one stem there is a scale is mentioned. Clear? Now on the next we are going to talk about the working. When the hydrometer puts in the liquid, the hydrometer floats in the liquid. If the liquid is denser, then the hydrometer does not need to sink very low to displace in its own weight of liquid. If the liquid has a low density, it will sink much deeper. In case of hydrometer, there is inverse relation between length of calibrated scale and density of liquid. If density of liquid is higher, the hydrometer will be less displaced. If the density of liquid is lower, the hydrometer will be greater displaced. Clear? Now we are talking about the uses of hydrometer, where the hydrometer are going to be used. Hydrometer are calibrated for different uses such as lactometer, secrometer and alcoholometer. Now first we are going to discuss about the lactometer. Lactometer is used to measure the density, creaminess of milk. Note that density of milk is 1.6 times greater than the density of water. Milk is more denser than water. Clear now? Now we are going to talk about the secrometer. Now there is a secrometer, that a secrometer is used for measuring the density of the sugar in a liquid. Now there is a alcoholometer. An alcoholometer is used for measuring high level of alcohol in spirit. Now we are going to talk about the upthrust in air. We have discussed about the upthrust force in the previous lecture. So today we are talking about that upthrust force does not only exist in liquids, it will also exist in air or gases. Examples: a balloon filled with a helium gas, a gas which is lighter than air, will be pushed upwards by the denser air when it is released. This is because upthrust is greater than the total downwards weight of the helium and the material of the balloon. Clear? Now we are going to talk about the helium gas balloon. Now air is denser than helium gas. Clear? Means air is denser than the helium gas and the material of balloon. Therefore, an upthrust is applied on balloon and the helium gas balloon as a result move in upwards direction. As we have told in a previous topic, that if the density is lighter, if the density is less, then it will be float or moves upwards, and if the density is greater, it sink, it's moved downwards. So helium gas is lighter as compared to the air, so it moves upward. Look at this one diagram. In a balloon there is a helium gas, so the air is more denser as compared to the helium gas. That's why helium gas balloons are moving in a upward direction. Clear now? Now we are going to talk about the info. Must keep in mind that Different fluids has different density, means different, all the fluids have their own densities. We have given you the examples. That examples, a steel ball floats in mercury because the density of mercury is greater than that of steel, while that steel ball will sink in the water because density of water is less than that of steel. Note, the density of steel is 8 times greater than the density of water. That's why it's going to be a sink in the water. Now we are moved to our next topic, that is the elasticity. Introduction, that in everyday conversation, if someone speaks to you about an elastic body, we probably immediately think of a rubber band. A rubber band, flexible, yield a great idea to a destroying force. Deforming means change in shape, and yet it returns to its original length after the destroying force is removed. Clear? Now that elasticity, the definition is the property of solid materials to return to their original shape and size after removal of deforming force is called elasticity. Deforming force is that force which produces change in shape and size of solid material. Clear? Now explanation. Look at the examples that we are in explanation. We are discussing about the example that when an archer shoots an arrow, it bends the bow, which springs back to its original form after the arrow is released. When a tennis racket hits the tennis ball, the shape of the ball is destroyed. And deforming means change, but its original shape when it bounces off the tennis racket. Look at the diagram. Look at this one diagram. It's changed the tennis shape, and after when they remove, the tennis will becomes its original shape. Look at this. When we over the arrow, what comes, that it's also comes in their original shape. Now the tennis ball. A tennis ball is flattened by the contact force exerted on it by the strings of the tennis racket. Likewise, the strings of the rackets are deformed by the contact force exerted by the ball. The two forces are interaction partners. Clear? Now plasticity or inelasticity. Not all the materials return to their original shapes when the deforming force acting on it is removed. Material that do not return in the original shapes after being destroyed are said to be inelastic material. Clear? It's not possible that all the materials you are applying a force and always they comes back to their original shape. Some materials not come back to their original shapes. That is called, those materials are called inelastic materials. Clear now? Now the next is plasticity. The property of solid materials that it does not gain its original shape and size after the removal of applying force is called plasticity. When elasticity is the property of solid material that it gains its original shapes and size after removal of applying force. Clear? Now examples of elastic materials are rubber band, springs, and a rubber ball. Now the examples of inelastic materials are that the inelastic materials example are plasticine, a soft molding clay material used especially by children. Clay dug. Look at this picture diagram. This diagram, look at that. These are the clay and the dug examples that they are able to come back to their not come back to their original shape. They are going to be a change. Now the next one is a elastic limit. Now what is the elastic limit? That most materials are elastic up to the certain limit known as an elastic limit. We say that elastic material are come back to the original position, but they have also they have their own limits. Most materials are elastic up to a certain limits known as the elastic limits. Beyond the elastic limits, material will not return to its original shape, dimensions, length, breadth, etc. Break or permanently deforms, shape change when the deforming force is removed. So, next topic we will discuss inshallah in the next lecture. Allah Hafiz.